Looking in the Building Energy Efficiency Standards, or the Bs as we sometimes refer to it during this course, Section 10-103.1, little c, 3, capital B, little Roman numeral 1, requires that an acceptance testing course have a lighting technology section. So this section is going to suffice for that in this course. So let's get cracking and move through this so we can get to the things that we really want to know. In prehistoric times, primitive man strapped a flaming fruit bat to a stick to light his cave. But soon, humans decided that they would like a better source of illumination, one that typically doesn't smell like a flaming fruit bat. So all kinds of vegetable oils and animal tallows and waxes were used for oil lamps and candles, but once society got bigger, they needed a bigger solution, and that bigger solution was whale oil. And if you're wondering what all those whaling ships were out there on the high seas hunting all those whales for, it was whale oil for lamps and ambergris, which is the sperm in a sperm whale's head. That was used for medicine and cosmetics. Now we also had petrochemical oils and things such as kerosene, but the next big evolution in lighting was gas jets. They had gas works in London that produced many amounts of many large quantities of lamp gas from coal and coke and steam. Modern gas mantle made these things work even better. Lord Kelvin determined the value of absolute zero and determined the colors that most materials glowed at specific temperatures. This was put to practical use in the first incandescent light bulbs. A modern incandescent bulb has a lower vacuum than an older one and has inert gas included in the envelope. The bulbs don't live as long, lamps don't live as long, but they are brighter and whiter. We're going to be looking at lighting units. The first three of these are important to you as an acceptance test technician. Here we see the lumen output listed for a lamp. There it is, 840. The lumen output of a lamp is every scrap of light that it produces in all directions. As shown on the slide, 1 lumen would pass through the 1 square foot opening in the 2 foot diameter sphere shown, and this is a 1 Candlepower point source sitting in there producing light that's going out in all directions. A lumen gets through that hole. Luminance occurs when light passes through or reflects from a surface. Illuminance is light that strikes a surface, and a good way to remember this is it falls down on the surface, and it falls down and strikes the surface because it's ill. When you're ill, you fall, so illuminance is light falling on and striking a surface. Now, if 1 lumen falls on 1 square foot evenly, then the illumination, if you spread that 1 lumen of light over 1 square foot, the amount of illumination here is a foot candle. If you take that same lumen of light and spread it out over a square meter, you're going to have a lux. Now, foot candles are typically considered to be the American measurement and lux somebody else's. This is not necessarily true. However, it is important that you know that the conversion ratio is 10.76, and which way does it go? Well, it works like this. One lumen, if you think of it as a spoon of peanut butter spread out on 1 square foot, is going to be of a certain thickness. If I take that same tablespoon of peanut butter and spread it out on this much larger surface, then it'll be a thinner coating, and therefore this will not be illuminated as brightly as a foot candle. We also have reflectance. So when you're looking at a surface, light is illuminating that surface. So this is illumination, and then bouncing back off, and that is luminance.